Hey guys, what's up? I'm Hugo from TechCornerTV, and behind me is already my setup for testing the Hantek DSO2000. I decided to retest this oscilloscope since I got a lot of issues, especially with low voltage measuring and using the auto function. As you can see in my oscilloscope showdown and firmware upgrade videos, you have in the description and on the top of the screen the links to watch the videos. And also, while preparing to record this video, I got a lot of hangs and freezes just by using the offset while evaluating a signal over 1 MHz. If you didn't watch those videos, I recommend that you watch them also and probably first. So I got a lot of comments on those videos. In the oscilloscope showdown and firmware upgrade videos, we can summarize what you guys asked to basically test again after the latest firmware upgrade and check if the voltage reading is more accurate, and also do some more exhaustive bandwidth measurings. So that's exactly what I'm going to do. Regarding the hangs and freezes I got while preparing to record this video, some users said that with the latest firmware of February 10th, the problem is solved. But since my unit is using the firmware from January 18, the first thing I'm gonna do is upgrade my unit firmware again and redo all the voltage testing. In short, the summary of topics for this video is the following, and I added chapters in case you want to jump to a specific section of the video. For bandwidth tests, since the date of recording of the review and oscilloscope showdown videos, Owen was kind enough to send me the XDG 2100 to review. You have the review also on the top and in the description, but that means that I now have a 100 MHz function generator to better test this equipment. I bought also a fast edge signal generator. This is a TDR, time domain reflectometer, but this one is not fast enough to produce a signal with a rise time lower than 1 nanosecond. That is needed to test the bandwidth of the oscilloscope using this method. I'm working on a solution, but I was unable to present it for this video, and I'm really sorry for that. So without further delay, let's start testing stuff. So as I told you before, the first thing I am gonna do is to upgrade the oscilloscope firmware. To do that, we go to Utility and Update. You have a whole video on this on the channel, and we will select Start Update, and let's see what happens. Okay, so we have the oscilloscope updated. He asked to restart. Let's see if this went all right. It's starting. Okay, it seems everything is okay. We have the settings again. Let me just take this out, the sound. Yeah, and we have now in here the 220210 firmware. So yeah, it's upgraded. Okay, let's start the testing. Okay guys, I have here the oscilloscope ready for testing. I don't even connected anything to the oscilloscope, and it's already with 78 millivolts. I will try to bring this down to a scale more near the voltage that I want. Oh, not like this, like 100 millivolts. With 100 millivolt scale, I have in here 4.5 millivolts, and that's about the same that I have here on the how we call it, on the multimeters. On the Siglent 4.0, well, 6 to 10, and also here on the Unity that is also giving me a value more or less about the same. Let's connect this and see what we have. Okay, connected. Okay, let's start injecting some current or some voltage in the system. I will start with 5 millivolts. Please notice that the multimeter, even without having any current, any voltage, it's already registering 4 millivolts. So right now I will connect the channel or power on the channel 1, and we have right now on Siglant 8.4 millivolts. That's about the same we have on Unity, so pretty nice. In terms of Rigol, let me do an auto set and also an auto set here on the Hantek. Well, the Rigol says we have 8.38 millivolts, 12. Let me check, 13. Yeah, it's oscillating, but yeah, the average it's about 9.2 millivolts. In the voltmeter of the Hantek, it says we have 16 millivolts, 16 also on RMS, and 14 on average. Okay. It's not so far from what we have on Rigol, and also, well, it's almost the double what we have on the multimeter. But anyway, I think it's better than we used to be. Let's increase 5 millivolts. It's a very low voltage, so let's put this on 10 millivolts. Okay, with 10 millivolts, let's do a key auto set again on the Rigol. And an auto set again on Hantek. Well, the Rigol right now says we have, well, it started with 11 millivolts, but after that it increased the voltage. And right now it says we have an average of 14 millivolts. The multimeter says we have 13 millivolts and on both. So I don't know if I have any issue with my linear power supply with this low voltage, if I can trust on my power supply, to be honest. In here, it's a bit far from the other two, so the Rigol, it's with an average of 15 to 16 millivolts, it's almost the same that we have here. But on the Hantek we have 21 millivolts and 18 average and 20 RMS. So yeah, it's not perfect, but even so, I think we can live with that. Let's pass this to 50 millivolts. With 50 millivolts, let's do an auto set on the Rigol. He likes that. Okay, and also we have, without auto set, we have 59 millivolts, average about the same, and 59 to 60 on RMS. Let's do auto set on the Hantek. While it does, we can check the Rigol. The Rigol says we have 55 millivolts RMS and an average of 54. 53, it's what we have on both multimeters. So yeah, okay, it's near. This one, it says on the voltmeter 58, 59, average also the same, and also the same in RMS. So it has a little bit difference, higher than the Rigol, but well, this is not a Rigol also. Okay, so let's double this to 100 millivolts. Okay, in terms of millivolts, the Rigol says 106 with an average of 103, And that's more or less the same we have on the multimeters. This one has 102, almost 3, yeah, and the same here on Siglent. In terms of the Hantek, it says 108. It still have that 5 millivolts difference. 107 on average and 107 on RMS. Let me just do an auto set on the Rigel and see what is the values that he gives us now. So we have 104.4. It's 1 millivolt over 1 to 2 millivolts over the voltage that we have on the multimeters. Yeah, I'm good with this. Let's move this to 250, increasing. On 250, this one, the Hantek, it's pretty near, 253 before the auto set. 252 to 53 on average, and the same on RMS. Let's do an auto set. And the Rigel says 256. I'm doing an auto set also on the Rigel. Just a moment while it does. And the voltage on the Rigel keeps the same, 254 to 55. That's again 2 more volts, 2.5 more volts that we have on multimeter. We have 252 on Siglent and 252 on Unity. The weird part on this oscilloscope, and that was my main critic on the showdown comparison on the oscilloscopes, is the auto set. When we use the auto set, the voltage will not be as near without the auto set. I don't know why. When we change without doing the auto set, the voltage will be more accurate than after the auto set. So with the auto set we have 263 and about the same, and VRMS and also average. Okay, moving on to 500 millivolts. I'm doing quite low voltage testing because that was one of the main issues. As you can see, changing the voltage without the auto set, it gives me 510 on the voltmeter. It's about the same on average and RMS. On average we have 507.8. On the multimeters we have 502. This one 502 also, 0.2, 0.7, so it's negligible, the difference. And on the Rigel we have 505 on VRMS, and also on average 504, 505. So we still have a 3 millivolts difference between the multimeters and the Rigel. And to be honest, I'm a bit surprised with this because before recording this I did some tests, and it was almost the same values as the multimeter, so I think it might need some calibration or something like that. Let's do an auto set in here to see if the value keeps the same. Well, this time it was much more near the multimeter, 503. That's more or less the values we have on the multimeter. Let's do again an auto set to see if it stays with the same, 503 and 503. So pretty nice. Yeah, I'm going to take this to 800 millivolts. That was a voltage that one of our viewers asked me to test. So we have 797 on the voltmeter and yeah, about the same on average and RMS. Let's do an auto set and also an auto set on Rigel. Rigel says we have 804, and yeah, still 3 more millivolts than this one. So right now we have 801, almost 2 on the multimeters, and the Rigel has 805, 3 to 5. So this is much more near the correct value than the Rigel right now, and that is surprising. Okay, so let me take this to 1 volt, and we will increase the voltage right now. 1 volt. We have a 5 millivolts difference. Let's do an auto set. On the Rigel, we have. Let's see what we have here. We still have 3 to 4 millivolts difference. On average, 997, and RMS 997. So pretty damn good for this. The multimeter says we have 1 volt 0015. So this is really pretty near 1 volt. The less significant digit, it's negligible. And on the let me see, on the Rigel we have 100.007 millivolts, 1 volt and 7. Yeah, so yeah, we are good. It seems okay. Let's move this to 2.5. I must say, with this last upgrade, okay, we need to do auto set in here, auto set on the Rigel. And I was telling you that with this last update or upgrade, the oscilloscope seems to be much more accurate than it was on my previous tests. So kudos to Hantek for solving some of the issues. On very low voltage, it still has some issues. Okay. Now we have 2 volts and 53, same on average and on RMS, and on the multimeter we have 2.5 on Siglent and 2.499, so this is almost 2.5 also. And on the Rigel we have 2.514, yeah, a bit over. Also on average the same. Moving to 5 volts to speed this up. Okay, the multimeters have 5 volts 70, so pretty near. Also the unity, it's a bit lower, but yeah, also 5 volts. On Rigel, let me see, let's do an auto set on Rigel, also auto set on Hantek. Let's start by the Rigel. We have 5.24 volts. Yeah, it's good. I accept that. And 5.03. So almost the same. Don't see any difference in here. I accept this. It's a bit different of the multimeter, but both oscilloscopes have the same value. Then that might be because of the cables of my installation and stuff like that. So I take this as valid. Okay, moving on to 10 volts. We have to do auto sets because the voltage difference it's considerable. The Siglent says 10.001 volts, pretty near. Also the unity 0.993, so both are pretty near. The Rigel oscilloscope says we have 10.4, okay, acceptable also. And in here we have 10.1. The Rigel is 10.04 and this is 10.1. So a little bit over the values on the multimeter and the Rigel, but still For the voltage we are dealing with, I think we are okay. Moving on to 20 volts. Again, auto set on Rigel. The multimeter says 19.998. The unity, the Siglent says that. The unity says 1998.6. Okay, also near. On VRMS voltimeter on the Hantek we have 20.3, a bit over, and also the same voltage on the average and RMS. In terms of Rigel, well, it's exactly 20 volts. Well, it changed now to 20.01. That's pretty near, really pretty near. It says 20 volts right now. So on higher voltage, it seems to be much more accurate. Okay, moving to the last voltage, 30 volts. That's the maximum of my power supply. And let's see what happens. Well, we don't have to, without doing an auto set, it says 30.3. Let's do an auto set, same on Rigel. Well, Rigel before the auto set it had 30 volts. Right now it has 29.99, so it's the 30 volts. We may consider that the average it's on 30 volts. And this one is about the same. Yeah, it keeps the same after the auto set, so it's okay. The voltage indicated on the multimeters, it's about the same, 29.995 or 95. So the least significant digits are almost the same. I'm happy with this. Well, the worst part is really, let's put this again on. Okay, we are again on 10 millivolts. Let's do an auto set. And yeah, with this one, the problem it's okay. Let me just take this to 10. Yeah, 10 millivolts. It's the one that has more difference. Let me put here the Rigel also. I don't know what is going on with the Rigel, but okay. Yeah, in the very low voltages, it has some difference. But the Rigel right now it's doing the same. So I cannot judge this when my 4 times the price, 4 or 5 times the price of this one has the same voltage on this, and after I calibrated that. So yeah. Okay, let's do now some bandwidth measurement to see how it handles after these upgrades. For that, I'm going to take this out, and just to let you know, I have here my Rigel 300 volts probe. I'm using this on my, let me just take this out of the way to show you. I'm using this on my Owen XDG 2100 function generator. This is a 100 megahertz function generator, and I will use this device that was kindly sent for review by Owen. And I use this function generator to test the bandwidth. I will take the auto set first of all, and let's first of all put this on 1 kilohertz and on a square wave to check if the probe is correctly compensated. So in terms of auto set, no signal. Okay, I have to turn the yeah, it seems okay. Let me take out of the way this voltmeter. Yeah. Measure off. Yeah, the probe seems okay. The probe, yeah. It's with square lines. So let's start testing the function, the bandwidth. I will start with 25 megahertz square wave. Sorry, sine wave. Okay, let's move. For this, I will activate the measurement. I will also increase the amplitude for better measurement, as some of my viewers recommended me. Okay, so right now we have 25 megahertz. I'm using 2.5 volts peak to peak on the function generator, and I don't know why. I think that function generator has a problem that it normally uses the double of the voltage. So it shows here 4.24, but I don't think this is a problem of the oscilloscope, but it's a problem of the function generator. The sine wave seems it's a little jittery, but other than that it seems well fine. We can use the average to have a more stable sine wave. Let's move this to 50 megahertz sine wave. Okay, let's open this. The measurements are here. So the peak to peak now it's 2.8, it's a bit lower. Still we have the frequency of 50. So right now this is with half of the bandwidth. Oops, let's take me half of the bandwidth. This is the signal that you have. Okay, I'm moving on to 100 megahertz, and let's see what we get with 100 megahertz signal. Okay, I think it's on 100. Let's do an auto set. Yeah, this is 100 megahertz. I cannot increase anymore the time range. It's already in 2 nanoseconds. It's a bit jittery. Even so, okay, I think it has a decent signal. We can measure with this without any problem. In terms of measurements, let's see, it's generating with 100 megahertz with a peak-to-peak of 2.5 volts. So yeah, it's with a 2.5 volts, 100 megahertz, and we have a rise time here of 2. Let me do a single. Okay, so in terms of bandwidth, we have a rise time of 3.16. I should say that my function generator doesn't have a rise time below 1 nanosecond. On sine wave I cannot assure that, but I'm almost sure. So this value, I don't know if it's accurate. I will test it also with this TDR device. It creates a square wave that has about 1.5 nanosecond rise time. It's not the ideal. I'm trying to get a device like this that has picoseconds rise time, so it will allow me to better test this kind of devices. But anyway, right now this is what I have. Okay, let's power this on. Okay, the camera had a little hiccup. Okay, we have power. Let's start this, and take this out of the way for now. Auto set. Okay, so we have our square wave here. Let's move this out of the way. And yeah, it's a pretty good square wave. And yeah, let's first of all see what we have in terms of automatic measurement. So in this measurement we have a rise time of 2.84 nanoseconds. So yeah, I should say if we use the 3.16 nanoseconds that I have with the function generator, it will give us about 110 megahertz bandwidth. I have to say that I'm not really believing this device has that kind of bandwidth. Well, maybe it has, and the 2D10 it's only marketing and everything else, and by software we probably can have the 150 megahertz device. Anyway, what it says for using my function generator, it should have about 110 megahertz. Using this value from this TDR, time domain reflectometer, we have a value of, let me do the math, just a second. Okay, using this value, we should have a bandwidth about 120 megahertz. Again, I'm not sure if this is very accurate. Let's try, instead of doing this, use the cursors. Okay, take this out, and let's try to use the cursors. Okay, what's going on? Yep. So we should have the positioning about 10%, and the other side also about 10%. It should be around here somewhere. And no, this is too much. Okay. And in here. So this will give us about 3.24 nanoseconds, and for that it is the 100 megahertz. As I told you, this device should have a square wave with a response of below 1 nanosecond. The IC that creates the square wave in here, it's a 74 AC14N, and for what I saw in the specs, it only has the capability of doing about 1 to 1.5 nanoseconds rise time. So yeah, this is what I have for you in terms of the bandwidth. One other test that we must do, and let me take this out if I can, because this is a little bit hard to take it out. Okay, let's put this again in here and do auto set. Cursors off. Right now we are using the 100 megahertz bandwidth. Let me take this out of the way. Okay. And one of the problems I have, I even do a video before this one, was the offset changing, and this hangs again. This is not solved by the latest firmware, and this is a huge problem. Okay, let's try to power this on again and see what happens. Okay, right now let me show you. I have 100 megahertz signal. Let me take this out of the way, and let's move this again in. it froze. So it might be a problem of my unit. I don't deny that is a possibility, but this is awful. This is awful. This is very bad. Okay, let's try again. I will try with only 1 megahertz. I have a viewer that said even with 1 kilohertz that happens. So I believe that, well, I bought this device for myself short after they were launched to the market. So this is one of the first units that was on the market, and that might be the problem. I don't know. I didn't upgrade this device. It's as it came from factory, and it has no changes on firmware other than the official firmware from Hantek. Yeah, let's try. Right now I have 1 megahertz signal, as you can see. Let's see what happens if the problem still is here. Moving on, and yeah, already hangs. Totally froze. We cannot do anything. I think the channel is live with David. He left a comment on the other video I made on how to freeze this under 10 seconds. Thank you, David, for that. It was a very nice contribution. And he has there some tips that I will later try on this device to see if this problem still remains or not. Okay, one of the questions that was made is if I can measure ripples on the range to, let me see, 20 millivolts to 50 millivolts. So I will put my power supply on 30 millivolts. It's 35. It's about the halfway. And let's see if we can see the ripple in here. Auto set. Okay, right now we have DC in 100 millivolts. I will reduce this, and okay, well, the offset cannot be used for anything. This is awful. This is very bad. We are talking about a low voltage and a low frequency. Yeah, this is really, really bad. I'm not using the function generator anymore. I just connected here to my power supply, and I was trying to analyze the ripple as one of the viewers asked me. Okay, so let's put this in terms of 50 millivolts. And as you can see, yes, we can see, well, this is a linear power supply, so the ripple is very low. But as you can see, we can even do this. And I will not dare to, let me see if I can, no. This is awful. I cannot bring this down because it will hang the oscilloscope. But as you can see, you can analyze the ripple. Here is the noise, and we can see it like this. This is a very low noise on this power supply. It's not as good analyzing these kind of signals as the Rigel. Let me just show you on the top. Well, that kind of signal in here, it's much better to analyze, but even so, yes, you can. Okay, let me see another question made for a viewer. He was talking about the heating problem. Yeah, this device has a heating problem. On top, it gets pretty hot. It will not burn, but it gets hot. Even so, the problems I'm having here are not related with heating. I had some issues when recording the first videos, but this one it's a nonsense. When we move this, let me move down. Look, already froze. This is, oh, I have no words for this. What sometimes I wish to call is a piece of junk, but really this is a nice oscilloscope. It has a nice a big range of features, a protocol decoder, a function generator, and yeah, but it has so many bugs. I don't know. They have to try harder, to be honest. And I think this could be fixed with another firmware upgrade. So another question that a user asked was about the G3 on the screen using 800 millivolts signal. I will pass this to 800 millivolts, my power supply. Let me show you. And about the G3, I have to do a key auto set. Okay, this is a 800 millivolts signal. Well, the signal move a lot, that's true, but that's because this oscilloscope probably doesn't have the same algorithms that, for example, the Rigol and the Siglance and other brands have to stabilize the signal. And they give them pretty cool names like Ultravision and stuff like that. And this one, well, the signal is what you get from the line. So yeah, it's a bit jittery. Okay, one last question before ending this. Sometimes I will need to use it for a mixed signal 2 Hz and 500 kappa Hz. Does it behave on a low frequency? Let's test it. Okay, let's connect this again. The probe that is connected to my function generator, and let's put this on 2 megahertz. Okay, we have a 2 megahertz signal. Okay, the auto set in low voltage, in low frequencies doesn't work pretty well, or very well. Let me just change the time frame. Oh, I'm increasing, not decreasing. Okay, I have to decrease, yeah. And what's going on here? Okay. So right now we have a 2 megahertz signal. If I increase the sine wave too much, we are unable to see the whole sine wave. Okay. So we have to use some time, like I don't know, 20 milliseconds or even more, 50 milliseconds. And this is a 2 Hertz sine wave. To be able to see the sine wave, we have to use 50 milliseconds so we can capture enough information to show you the sine wave. Okay, so right now what we will do is pass this to 500 kilohertz. That's the frequency that the viewer asked me to test it also. Let's put this in 500 kilohertz. Right now it's 1 microsecond, and yeah, it behaves okay. No problems with that. I can change it. This is a sine wave. Yeah, it seems okay. Okay guys, let's wrap this up. And for me, in terms of low voltage, it seems to be a bit better. It gives you more accurate values. It still has some issues when pressing the auto set to get the values. It tends to be more accurate when you change the values and don't need to set the auto set or manually fix the voltage and the time domain of the signal. That was one of the problems that I had when doing the showdown video. Don't forget to see it. And in terms of voltage, it seems to be a bit better. Well, the worst part is that the problem that I had with freeze and the hangs when changing the offset is still there, and we cannot use it even on low voltage, on low frequencies, and that it's, well, that is awful. We cannot use this oscilloscope without fixing the offset, and every time I change the offset, the oscilloscope hangs. That is really awful. And well, and that is a big no-no, because I think this oscilloscope is it's well packed. It has some quality for the price that we have, but in terms of low end or entry line oscilloscopes, I still think that this one from Owen, this is the four channels module. You have the SDS1102 for 2 channels only, but yeah, it still is the the entry-level oscilloscope to buy if you want accuracy. It's a pity it doesn't have a function generator, and also it doesn't have the protocol decoder. To be honest, a function generator, considering the price of the SDS1102, you can buy a better function generator like the Hantek or Hantek for about the same price. It's not on the same device, but I prefer to have it externally, to be honest. It's more flexible and normally more powerful. So using the price of the function generator and this device, you will have the price of this Hantek 2D10 and the 2D15 also. But for protocol decoding, you have small devices, the SALAI. You can have SALAI clones. You can have that for, it's a logic analyzer, and you can have that for about $10, $5 to $10. It's pretty cheap, that device. And with that, you can also have the protocol decoding. It's not all on the same device, but yeah, this one is very accurate. It never hangs. Well, at least with me, it never hanged, even with long hours of work. Well, I don't know. I must say I love this device. It's a lot of stuff only on one device, but what you have a test equipment that has to be good while testing. That's my opinion. And I have users that say it works marvelous. The other ones that say it's awful and they send it back. I'm in the middle. I love this, to be honest. I love this device, but it has serious issues to solve. And if they solve it, I have nothing bad to say about it. Okay, I think that's it for today. I hope that you enjoyed this video, and if you did, don't forget to give a big thumbs up. And if you haven't already, please subscribe, consider subscribing. And if you do, don't forget to hit that bell to activate all notifications and be the first one to be notified whenever I upload a new video. Stay safe, and I hope to see you in my next video. Cheers!